Good morning, students. Myself, Vijay Shankar from BC Department, Chevrolet Engineering College. Today, we are going to discuss about some more examples in the analysis of the linear system. In yesterday class, we discussed some examples. In this class, also, you can discuss about the examples in the linear system. Okay. We already completed this. H of t is equal to e power minus 5 into the magnitude of t, whether it is a stable or unstable system. Stable means you can satisfy the formula, the integral minus infinite to infinite. H of t is less than the h of t into dt, less than the infinite. Stability. If any given function, let us take the e power minus 4 into mu of t. Already we did that. It is a minus 1 by 4. We got infinite minus 1 by 4 is equal to infinite unstable system. Okay. And now we can take the one function, the t into cos t. The h of t is equal to integral minus infinite to infinite, the t into cos t into mu of t dt. When the mu of t changes as a 1, the limitations is also varies from the 0 to infinite, the t cos t into dt. Okay. Now, apply the u variable here, the t into sine t minus the integral of t, derivative is a 1, the sine t with the upper limit is infinite and lower limit is 0. And again, you can use the t sine t minus, it becomes a plus cos t integral c and infinite and the 0. Now it becomes t is infinite, here the t is infinite minus cos infinite and t is a 0, and again the cos 0 is a 1. Even if it is infinite, the value is there. Infinite, nothing but is approximately equal to the infinite unstable system. Unstable system. Got it, my students? Similarly, the e power minus t sine t also. E power minus t sine t mu of t. You can directly take that it is a sine t as e power jt minus e power minus j into t by 2z, and this is multiplied with the e power minus t, and the integral minus infinite to infinite is changed as 0 to infinite by keeping the mu of t is a 1 into dt. 1 into dt. Okay, my students. So now you can change these values 1 by 2z into is e power, take the minus t as a common, 1 minus j whole divided by, with respect to, we are applying the t, 1 minus j into minus 1. For another integral also, minus e power minus t you can take as a common, 1 plus j whole divided by minus of 1 plus j, with upper limit is infinite and the lower limit is 0. Got it, my students? So when you can substitute the infinite, both the terms, it becomes a 0. E power infinite is a 0. The term 1 by 2j into 0, and e power j is there. E power j, not the e power j, e power 0 is a 1. So 1 by 2j whole multiplied with the value is a 1 here, 1 by j minus 1. So I'm taking the multiplication of minus also, j minus 1. and here all the minus is there, becomes a plus, and 1 by 1 plus j, or j plus 1. It's totally, because we are applying the denominator, lower limiter, there is a minus is there. Put the minus here, the minus 1 by 2j, minus 1 by 2j into j plus 1 plus j minus 1 whole divided by j square minus 1. So minus 1 plus 1 get cancelled, 2j, and the 2j is also get cancelled. J square is a minus 1, minus 1 plus minus 1. So minus by the minus 2, 1 by 2. So it's a less than the infinite. Less than the infinite, then it is a stable system. Less than the infinite is nothing but it's a stable system. Got it, Martin? The next example, you can see the system produces the output. The system produces the output of y of t is equal to e power minus t mu of t. Y of t is equal to e power minus t mu of t for an x of t is equal to e power minus 2t mu of t. Determine the impulse response and the frequency response of the system. Impulse response means h of t, frequency response it is a h of omega. Given the output function e power minus t mu of t, and x of t is equal to e power minus 2t mu of t. So y of t given, now you can convert this into the Fourier transformation, e power minus t mu of t as 1 by a plus j omega, e power minus a t mu of t. The Fourier transformation is 1 by a plus j omega. What is the a here? 1. So y of omega is equal to 1 by 1 plus j omega, and x of omega is equal to 1 by 2 plus j omega. We need the frequency response. So h of omega is equal to the ratio between of the two functions, 1 by 1 plus j omega by 1 by 2 plus j omega. It becomes of 2 plus j omega by 1 plus j omega. And now the h of omega is converted into the 2 plus j omega in the numerator as 1 plus j omega whole divided by 1 plus j omega. That is equal to 1 by 1 plus j omega plus 1. Why it is a plus 1? 1 plus j omega by 1 plus j omega is a 1. H of omega is equal to. So we got the frequency response h of omega 1 plus 1 by 1 plus j omega. Now convert this into the impulse response. H of t is equal to. The h of t is equal to 1 by 1 plus j omega means e power minus t mu of t plus 1 is a delta of. Okay. The impulse response we got e power minus t mu of t. So delta of t e power minus t mu of t as an impulse response the inverse Fourier transformation of h of omega. So what is the h of omega? We got 1 plus, or otherwise 1 plus 1 by 1 plus j omega. 1 plus 1 by 1 plus j omega. Got it, Madam students? Now, the transfer function of the low pass filter is given as h of omega is equal to 1 plus k into cos omega t e power minus j omega t when omega value is less than the 2 pi by the p and 0 for omega is greater than the 2 pi by p. Is the equation we got for the rise time relation between the bandwidth. So determine the output y of t when the pulse x of t band limited in b hertz in terms of the frequency is applied as an input. So y of omega is equal to x of omega into h of omega. you have to, they are asking that it is a determine the output response y of t when the pulse x of t is band limited in v hertz is applied at the input. So h of omega is a given. We need to find the y of omega when we can take the input as a band limited signal up to the b. Okay. So how we got that function, as we know, the x of t minus tau plus x of t plus tau is a Fourier transformation of 2x of omega cos omega t. And x of t minus tau is the Fourier transformation is x of omega into e power minus j omega into t. For this function, the y of omega is equal to, we know, the x of omega and the h of omega as of convolution time domain property. The given x of omega can substitute 1 plus k into cos omega t power minus j omega tau. Multiply with the x of omega, the x of omega into 1 e power minus j omega tau. See, for this function, we already know the time shift property saying that the x of t minus t naught, its a Fourier transformation is e power minus j omega into tau, not the tau, here the t naught I am taking, t naught into x of omega. Same way, in the frequency, we have the x of omega into e power minus j omega tau. Instead of t naught, here the tau is there. For this function, the inverse Fourier transformation is x of t minus tau. Okay. Similarly, the x of omega cos omega t e power minus j omega t. Cos omega t means we have e power j omega t plus e power minus j omega t by 2, and we can take the e power j omega tau. I will explain here. So let us take the x of omega here, x of omega into cos omega t and the e power minus j omega tau. This is also tau, my dear students. So the cos we can write as j omega tau into e power, not the into, minus e power, not the minus is a plus, minus j omega. Let us take this here also, the minus and the minus is there. Please get cancelled. So let us assume this is a t or the small t here. E power minus j omega tau is the totally divided with the 2 into x of omega actually. Now you can write this function as a 2 parts e power j omega t into e power minus j omega. Take as a j omega as a common term. J omega, the t minus tau as a one function into x of omega plus in the second term, the 1 by 2 is a common, my students. E power j minus j omega you can take as a common t plus tau into x of omega. Okay, into x of omega. Now here also there is a shifting operation is there. Shifting operation only, the x of omega into e power minus j omega, instead of t naught, there is a t minus tau is there. T minus tau. For that function, the 1 by 2, you can cross multiply that, the 2 we can take here, 2 into x of cos omega into x of omega into cos omega t. Okay. This function is x of t minus tau plus x of t plus tau. The advanced function and the delayed function is multiplied. Okay, my dear students. So after multiplying the function x of omega cos omega t e power minus j omega, what is the k value here? The k value is a 2. Is a cross multiplying this 1 by 2, you get in the frequency. So take the frequency is a 2x of omega. So 2 here, 2 to get cancelled, 2 into, and the 2 is multiplied. Let us cancel the 2. So the 2x of omega cos omega t e power minus j omega tau. The time domain function is x of t minus tau, x of t plus tau. X of t minus tau and x of t plus tau. So we got the two functions. The y of omega is equal to. The first term is in terms of the time domain, and the second term is also in terms of the time domain function. To get the y of t, now to get the y of t, f inverse of y of omega. F inverse of y of omega. The y of t is equal to, we got the x of omega e power minus j omega t as a first term is x of t minus tau, and k by 2, the x of t minus tau minus t, and x of t minus tau plus t. What it minus terms. So the y of t is equal to x of t plus k by 2 into the total function x of t minus tau plus x of t plus tau. Is delayed by the tau only. So finally we got the output y of t in the time domain function. Okay. Is the two factors. The first factor f inverse of x of omega e power minus j omega tau as is x of t minus tau, and the k by 2 as a function x of omega e power minus j omega t cos omega t. Cos omega t is x of t minus tau and x of t plus tau function when it is a k by 2. Okay. I'm taking as a k as a 2 to get cancelled. As a k factor is a 2. You simply can write as x of t, the k by 2 into x of t minus tau plus x of t plus tau. Got it, my students? Then determine the maximum bandwidth of the signal that can be transmitted through the low pass RC filter as shown in the figure. If for this bandwidth the gain variation is to be 10% and the phase variation is to be within the 7% of ideal characteristics. So let us take this diagram we have. What they're asking, determine the maximum bandwidth of the signal that can be transmitted through the low pass RC filter. As shown in the figure below, it is RC filter. If over this bandwidth, the gain variation is to be 10% and the phase variation is to be within 7% of the ideal characteristics. The given diagram with the resistance RC filter, 20 kilo ohms, 10 nanofarads, and 30 kilo ohms as a load output side. RC network transferred to the S domain function. S domain function. The VI of S is equal to VA of S and output power V naught of S R into, I'm taking this function, the capacitor as 1 by C into S. 1 by C into S minus 2 S. Let us take the H of S is equal to, we need to find the H of S is equal to V naught, the transfer function, V naught of S by the VI of S. Okay. What is a V naught of S? These two are in the parallel. So R is parallel with 1 by C into S whole divided by VI of S is equal to, these two are parallel and you can add the function R, the series 1 by CS plus R. These two are parallel and the plus R is the input function. VI of S is equal. Okay. Now I can simplify the function here, the R by S into R plus 1 by CS as a parallel function. In the denominator also, R by CS whole divided by 1 plus R plus 1 by CS plus R. Okay, the parallel function R by CS whole divided by R plus 1 by CS, and is again the whole divided by R by CS whole divided by R plus 1 by CS plus R. Now take the LCM here. The denominator is a CS, means 1 plus CS into R. CS get cancelled, and R by the numerator itself, R by 1 plus RC into S. 1 plus RC into S is a numerator. CS get cancelled. And here also, the same thing is a parallel. So R plus R by 1 plus R into CS plus R. Again, you can add the function R. Denominator is the same. Let it be the R as a numerator and R plus R into 1 plus RC into S. The denominator 1 plus RCS and 1 plus RCS get cancelled. Okay. So take the R is a common, and 1 by 1 plus RCS. Okay, take the R and R the common, and you can cancel the R in the numerator. Here the 1 is there. 1 plus 1 is a 2. 1 by 2 plus RCS. Here the R is given as 20 kilo ohms as in the input side, and C is the 10 nanofarads. You can substitute 1 by 2 plus S into 10 into 10 power of minus 9 because it's a nano, multiplied with R as 20 kilo ohms. 20 into kilo is a 10 power 3. Got it, my students? Simplify this function. The H of S is equal to, we got 10 into 20 is 200. 10 power minus 9 and 10 power 3 is 10 power minus 6 is remain. 200 into 10 power minus 6 is a remaining. 2 plus 1 by, after substituting the value. Okay, my dear students. So still it is 1 by 1, 2 plus 200. You can write as a 2 into 10 power 2 is 10 power minus 4. 10 power minus 4. Got it, my dear students? And the S is also there. S term. 10 power minus 2. Again, you can simplify this function, and we'll get 10 power minus 4 is a denominator. The 2 into 10 power 4, 10 power minus 4, sorry, plus 2s in the numerator is a 10 power 4. So finally, we got H of S is equal to, I will write here, H of S is equal to 10 power 4 by the 2 into 10 power minus 4 plus 2s is a function. So we got here the same 10 power 4 by the 2 into 10 power of minus 4 plus 2 into s. It is a plus only, my dear students, because 1 by we are writing here. It is also the plus 1 by 10 power 4. Then only you get the numerator. 2 into 10 power of 4 plus 2 into s. Got it, my dear students? Still further they are modifying, and you can find out the magnitude and the phase also. Magnitude and phase. Let us see here the magnitude. They are saying 1 by 2 into 10 power 4 by the 2 into 10 power 4 plus 2s. The s is becomes a j omega. S is becomes a j omega, and h of omega is equal to. We'll get the magnitude and the phase. So I will explain that. We got 10 power 4 whole divided by 2 into 10 power 4 plus 2 into s. So what is a s here? The substitute the j omega, h of s we got. Let you can take the s is equal to j omega. S is equal to j omega. What it matters? So h of omega or j omega is equal to 10 power 4, means you can write as 4 zeros whole divided by, take the 2 as a common, 2 as a common, s plus 10 power 4 you can write as a 10,000. Divide with the 2 of 10,000, it becomes a 5,000 in the numerator. S is equal to j omega, sorry. Here the s is equal to j omega, j omega. So h of omega is equal to, shortcut notation if I am writing, h of omega is equal to 5,000 divided by 10,000 plus j omega. 10,000 plus j omega. Okay, the same we got here, it's also 5,000 by j omega plus 10,000. Now you can convert this into the magnitude. H of omega is equal to 5,000 whole divided by, here the complex function under root of x square plus y square. What is the x square? Here there is a x square is there, my students. Totally the 10,000 is there. The square also will get in the denominator. Omega square plus 10,000 square. And the pi of omega is equal to minus tan inverse of omega by the 10,000. Imaginary coefficient is omega, and real term is at 10,000. Okay, my students. In this, they are substituting that omega is equal to 0. At omega is equal to 0, the magnitude is becomes 0.5. But there is a 10% variation is a gain over the bandwidth B. There is a 10% variation with in the gain over a bandwidth B. The h of omega is equal to be got as a 0.5. Add the omega is equal to 0, my students. So 0.5 minus the variation of gain is a 10%. You can subtract the 10% of the 0.5 from 0.5. That is a 5 only, 0.05. The 0.5 that minus the 0.05 is a 0.45. Okay, my students. The 0.5 is a 10%. Similar, the h of omega, the magnitude is becomes a 5,000 pi under root of b square plus 10 power 8. Why it is a 10 power 8, my students? It is a 10 power whole square. Okay. And b square plus 10 power 8 is equal to the 5,000 by the 0.5 whole square, and we get the b is equal to 4.84. And b is nothing but the frequency, the omega m on. Okay, the frequency omega m. B is minus b to the b as a low pass filter, the same as minus omega m to the omega m. And we got the b is equal to 4.89 kilohertz. 4.89 kilohertz. So b is equal to omega m is equal to, or omega is equal to 2 pi f. we got the omega as 4.84 into 10 to the power of 3, because it's a kilo, is equal to 2 pi f, and f is equal to 4.84 into 10 to the power of 3 whole divided by the 2 pi. So after calculation, we will get the 770.8 hertz as a frequency. Okay, my dear students. And similarly, if the phase also, the phi of omega is equal to tan inverse, we got the omega is 4.84 kilohertz. Substitute here, kilohertz means 10 to the power of 3. And already the 10,000 is there, 3 zeros is get cancelled, remaining is a 10 only. Okay, the phase at the frequency is 770.8 hertz, and the pi of omega is minus 25.83%. Okay, got it, my dear students? So next one is the second part of this unit is a convolution and the correlation of the signals, my dear students. Convolution and correlation of the signals. So what is a convolution and what is a correlation? Convolution very is important because it relates the input signal and the impulse response of the system to the output of the system. See, the convolution is important because it relates the input signal and impulse response of the system to the output of the system. So the input function and a linear time invariant system as impulse response h of t to get the output response y of t with the input function x of t. Okay, that is nothing but the correlation. Y of t is equal to x of t with the convolution of h of t. And what is a correlation means? Correlation is again a mathematical operation that is similar to the convolution. Correlation also uses two signals to form a third signal. Two signals, x of t, the h of t, and the output response is a y of t. It is very widely used in practice, particularly in the communication engineering. Basically, it compares the two signals. Correlation means comparing the two signals in order to determine the degree of similarity between them. Why we are comparing the two signals? To get the third signal. When we are comparing the two signals to get the third signal, because it compares the two signals in order to determine the degree of similarities between the two signals. Radar, sonar, and the digital communications use correlation of signals very extensively. Correlation may be cross correlation and autocorrelation. What is the different types of correlation means? Autocorrelation and the cross correlation. Autocorrelation is comparing with the same signals. Okay, as representing of R x of tau, or x y of tau, with the comparison between the same signals. Autocorrelation. And cross correlation means for the different signals R x y of tau and R y x of tau or something. Different signals or x1 and x2 signals. Got it, my dear students? When one signal is correlated with another signal to form a third signal. One signal is correlated with another signal to form a third signal. It is called the cross correlation. When the signal is correlated with itself means the same signal to form the another signal, it is called the autocorrelation. For different signal comparison occurs cross correlation. Means one signal is correlated with another signal to form a third signal. is called the cross correlation. When the signal is correlated with itself to form another signal, it is called autocorrelation. Okay, my dear students. In this, we have to learn the convolution theorems associated with the Fourier transformation, graphical representation of the convolution of the two signals, and correlation and energy density spectrum, power density spectrum, and Parseval's theorem. The second part of the fourth unit is the convolution and the correlation. In this, you have to learn the properties of convolution and the convolution theorem and graphical representation of the convolution of the two signals, and also the correlation, the two types. One is autocorrelation, the cross correlation. In that, the energy density spectrum and the power density spectrum. Energy density spectrum is a psi, and power density spectrum is a S. And also the Parseval's